last time we have seen the definition of two variable functions and also the definition of three variable functions. So let us see some of the examples to find out what could be the domain of the two variable functions and what would be the range. So let us see the definition again. Definition of two variable functions. You might have remembered. So a two variable function f from set D to R, which is a real valued function defined on a set D, which is subset of R2. So a two variable function f is a rule that assigns unique real number of the codomain, unique real number z from codomain to each ordered pair xy in D. So when we say that f is a two variable function, so therefore we can write z, which is a unique real number or unique output for the function f, which is assigned to the ordered pair xy in the set R2. So when this xy is element from D. So in this case we say D is a domain of a function. Domain of f. Set R is codomain of f. And the range of f would be the possible outputs, all the possible images for function f, under function f. So it will be collection of all the elements z such that z is associated with ordered pair xy. So z is unique element in the codomain which is associated with, which is or assigned to the ordered pair xy, where this xy is from the domain D. Domain is what? Domain is those elements from the set of input which can be assigned to unique real number in the codomain, or those elements in the set of inputs which can produce some output, which can have image in the codomain. Right? So if we write, so if z equal to f of xy is a two variable function, z equal to f of xy is a two variable function, then we can say that x and y are independent variables. Independent variables. And z is dependent variable. This is why, because we have defined the function z equal to f of xy. That means z is depends on xy. We express z in terms of x and y. So we need x and y to express z. So z is depends on x and y, and x, y are independent input variables, so they are independent. But our output z is depends on x and y. So z is dependent variable and x, y are independent variable. So let us see some examples. Find the domain of function. Domain of two variable functions. So find domain of f. Also sketch. So first example, we can have function f to be square root of x plus y plus 1 upon x minus 1. The second function f would be x into ln of y square minus x. The next function is under root of 9 minus x square minus y square. The next one is f equal to under root of 2x minus y. Under root of xy. Under root of x square minus y square. Under root 1 minus x square minus under root 1 minus y square. Under root 1 plus under root 25 minus x square minus y square. And the last one is f equal to under root y minus x square upon 1 minus x square. So these are the functions. We have to find the domain, and then we have to sketch geometrically, because all the domains, all these are two variable functions. That means the input is given from R2. So we have to find the domain and sketch this domain into R2. So what kind of elements would be there? Those can be given as an input to the function f. So let us see solution to the first example. So the function is under root x plus y plus 1 upon x minus 1. So what is there in this function? So for this case, the function will not give output to us. So there are two things we can identify here. So in the numerator there is a square root, right? And in the denominator there is a polynomial, which is linear polynomial, and this polynomial can have 0, can have root in real numbers. In the numerator, the quantity is square root of something. So if the quantity inside the square root is negative, we cannot find the square root, right? Even if the quantity inside the square root is 0, we can find the value. If the quantity is positive inside the square root, we can find the value. But if the quantity is negative, we cannot find the value of square root. So one thing is that if the quantity inside the square root is negative, we cannot find the value. And the second thing is, if the denominator becomes 0, in that case also we don't have the output, because we cannot divide something by 0. So f of xy equal to square root x plus y plus 1 upon x minus 1. So even the function is not defined when the square root contains the negative value or the denominator is 0. So the function is not defined if the quantity inside the square root is negative and the denominator is 0. So in which case, so when this quantity is negative and when this denominator is 0, so quantity is not defined if x plus y plus 1 is negative, and the second case is if x equal to 1. Right? So what should be the domain of the function? Therefore, domain D should be what? The domain D, it should be a subset of R2 that should not contain this kind of element. Which kind of element? The order pair xy, for which this happens. So what are those order pairs for which it should happen? So we collect the order pairs from R2, order pairs xy from R2, such that for which it should not happen. So what should happen? So x plus y plus 1, it should be greater or equal 0. This quantity should be either 0 or greater than 0. And the second thing is what? X equal to 1 should not be the case. That means what? X should not be equal to 1. Or x minus 1 should not be 0. Right? It means what? The domain is what? Collection of order pairs xy such that x plus y should be greater or equal minus 1 and x should not be equal to minus 1. Sorry, x should not be equal to 1. So this is the domain for this function. So if we consider this set, so every element of this set will have image in the codomain, because every time we will get some output in the codomain, unique output. So how we can sketch this domain D? So it is subset of R2. So what? Collection of order pairs from R2 such that x plus y is greater or equal minus 1. So try to draw the inequality. So x plus y equal to minus 1. So if x is 0, y is minus 1, and if y is 0, x is minus 1. So this is the line x plus y equal to minus 1. So this line makes two divisions of our domain of the plane xy plane. The line x plus y equal to minus 1 makes two divisions, below this line and above this line. So these are the two divisions made by this line. We have two restrictions on R2. What are those restrictions? One is this and other one is this. So what is this region? What is the region for which x plus y greater or equal minus 1? Greater or equal minus 1. So my boundary line should be there in my domain because equality is there. X plus y can be minus 1. So try some points. So if I choose 0, comma 0, so 0 plus 0 is greater than minus 1, right? So this point should be there. If I choose this point minus 2, comma 0, so it is minus 2 plus 0, which is less than minus 1. So it is not the case. If I choose this point minus 1, comma minus 1, so it is minus 1 plus of minus 1, so it is minus 2, it is less than minus 1. Minus 2 is less than minus 1. So these kind of points, that means those are lying below this line, would not be there in the domain. So what should be there in the domain? So domain should contain the points above the line. So this is the one restriction, x plus y should be greater or equal minus 1. So domain should be in this part, in this division of R2. The other restriction is x should not be equal to minus 1. So what are those elements for which x is minus 1? That means we have to observe the order pairs for which the x coordinate is minus 1. So what are those order pairs? So the order pairs are on this line when x is equal to 1. What we want? X should not be equal to x should not be equal to 1. Means what? We have to delete those order pairs for which the x coordinate is 1. So we should delete the order pairs which are lies on this line x equal to 1. So we have removed the line x equal to 1. So our region D is a union of two parts. Right? So union of these two parts is the domain. Right? What will be the range? So if this is the function, so x should not be equal to 1. X can be positive, x can be negative. So if x is positive, not equal to 1, and positive greater than 1, this quantity will be positive. Square root is always positive for this region. So it depends on this value. Square root may be 0. So numerator may be 0 or positive. Denominator may be. X should not be 1. So if x greater than 1, denominator is positive. So function can give all the positive values. If x less than 1, so the denominator will be negative, and we can have the negative value of function back. So the range can be, so function may take all the values between minus infinity to plus infinity. Right? Let us see the second example. Solution for second example. So what is the function? into ln of y square minus x. So it is a function. So now observe which part of the function makes problem to us. In which case we cannot have image in the codomain, or we cannot have output of the function. So this is x, so it is defined everywhere, ln of y square minus x. So logarithmic function, so it depends on the domain, of logarithm. So the nature of the logarithmic function. So logarithmic function will not give output if we are trying to find output of 0 or image of 0 or image of negative quantity. So if this quantity is 0 or negative quantity, so the logarithmic function will not give output. So what? This function is not defined if, when it will be not defined, if the quantity inside this bracket is negative or 0, because domain of logarithmic function is in one variable 0 to infinity, open bracket 0 to infinity. So if this y square minus x is negative and 0 also, so what should be the domain? It should be collection from the R2, collection of order pairs from R2, for which it should not be the case. Means what? This quantity should be positive, such that y square minus x should be positive. That means what? Domain should be order pairs in R2 such that y square should be greater than x. Y square should be greater than x. So try to sketch this domain. So it is subset of R. D is subset of R. So the domain will be in R. Okay. So it is collection of elements of R2, order pairs from R2, for which y square is greater than x. Square of second coordinate should be greater than x, first coordinate. So it is the graph of x equal to y square. So the parabola x equal to y square. The parabola x equal to y square. What we should have? Y square should be greater than x. So if I choose this point 1, 0, so y square 0 square is not greater than 1. If I choose this point 1, 1, it is 1 square equal to 1, but it is not greater than 1. Similarly for this point also, if I choose this point 2, 1, in this case also 1 square is not greater than 2. So what I should delete, what I should avoid? I should remove those points on the boundary of the parabola and those points inside this parabola. So what should be my region? Domain or the region. So it should be outside the parabola. boundary should not be there. So I remove the boundary of this parabola. So this should be the region, domain. So these are the elements for which this function will be defined. So this part will be domain of the function. We have to remove the points on boundary of the parabola and points that are enclosed in the parabola. X equal to y squared. What will be the range of this function? X may take any value. So y square minus x and the logarithm. So logarithm can take all the values from minus infinity to plus infinity. So the range can be minus infinity to plus infinity. Let us see next example. Solution to 3. So the function, what is the function? Under root of 9 minus x square minus y square. So it is a two variable function. We have to find the domain. We have to identify those points which cannot have image in the codomain, which cannot have the output. So it is only a square root is there. So if the square root is 0, we can have a value. If the square root quantity inside the square root is positive, we can have the value. But if the quantity inside the square root is negative, we cannot have the image to the function. In this case, the function is not defined if the quantity is negative. 9 minus x square minus y square is negative. So what should be the domain? So what should be the restriction? This should be the restriction. The quantity should not be negative. Therefore, what would be the domain? So it would be collection of order pairs from R2 such that for which the quantity should not be negative. It means quantity should be positive or 0. Should be greater equal 0. It means what? It will be collection of the order pairs from R2 for which x square plus y square should be less equal 9. Am I right? So this is the domain for function f. Try to draw this. So what should be the picture? What should be the region of domain D? Collection of points xy such that x square plus y square less equal 9. So x square plus y square equal to 9 would be the circle of radius 3. X square plus y square should be less equal 9. So it should be a disk of radius 3, including the boundary. So this should be the domain for function f. Now, what would be range for this function? What we know? The quantity inside from the domain. Quantity inside the square root should be greater or equal to 0. That means at least this quantity should be at least 0. If the quantity is at least 0, so the least value of the square root will be square root of 0 will be 0. So the least value will be 0. Why? Since 9 minus x square minus y square should be greater or equal to 0. The least value should be 0. Right? If this quantity equal to 0, it will be, output will be 0. And then what happens? What will be the largest value? What will be the maximum value? This quantity will be positive if and only if this quantity will be positive if and only if this is positive. That means x square plus y square has to be less equal 9. So the value of x square plus y square has to be at most 9. So this value would be at most 9. 9 minus x square plus y square. Then we can have the minimum value 0. So the least value of xy will be 0, 0, and in this case we will have the maximum value 9 minus 0. So maximum value 9 minus 0. That means square root of 9 minus 0. That means square root of 9. That means 3. So this can be the range. The next example. Solution to example 4. The function is under root 2x minus y. The same case square root is there, so quantity inside the root under square root should be greater than or equal to 0. So this will be not defined if this quantity is negative. So what should be the domain? So domain should have such kind of element for which this quantity is negative. So domain should collect all the elements, all the order pairs from R2 for which it should not happen. That means the quantity should be at least 0 or more than 0. That means it is such elements for which 2x greater equal 1. So try to sketch this region. So y equal to 2x. 2x minus y greater equal 0. So 2x minus y, 2x greater equal 1. So this is y equal to 2x. So y equal to 2x. So in which part 2x is greater or equal to y? In which part 2x is greater or equal to y? So here if x is 1, if x is 1, y is 2. So it is 1 comma 3. So 2x is less than 3. Right? 2x is not greater than 3. 2 is not greater than 3. If this is 2, this is 4. So if I take this point, it is 2 comma 5. So 2 into 2, 4 is not greater than 5. Right? So if I choose this point, 2 comma 3, so 2 into 2, 4 is greater than 3. So this should be the result. And the domain will include the boundary also. So this is domain D, for which 2x minus y will be greater or equal to 0. What will be range of this function? The least value, the least quantity 2x minus y from the domain should be 0, the least quantity, because at least the square root container should have 0 to get the output, to get the value. So root of 0 will be 0, and what will be the largest value? It depends on the values of x and y. So the values may be large. So this is the range. Next solution to 5. The function is f of xy equal to under root xy. Again, it is the square root. So the function will not have image, will not have output if the quantity is negative. So it is not defined if this quantity is negative. So what should have? This quantity should be either 0 or more than 0, large, greater than 0. Therefore, domain should have those points of R2 such that this xy should be greater or equal to 0. So when the product will be greater or equal to 0, product will be 0 if one of them is 0 or both are 0. So in which case the product will be positive. So simplify this, say xy greater or equal to 0 when both x and y are greater or equal to 0 or both x and y are less than equal to 0. So what should be the set? So those elements in R2 for which xy both are non-negative or xy both are non-positive. So it will be this region. In first quadrant, both the coordinates x coordinate and y coordinate both are positive, and if we include boundary, both are non-negative. That means boundary should be considered in this domain. And in the third quadrant, both the coordinates have negative sign. Both the coordinates are negative. So here also we should consider the boundary. That means negative x-axis and negative y-axis. So union of these two regions is the domain. What would be range? So function will have minimum value 0 because xy should be at least non-negative, at least 0. And they may have large value, depends on value of x and y. Next solution to 6. Solution to 6. You may try yourself. Function is under root x square minus y square. So again, the function will be not defined if the quantity inside the square root is negative. So what should be the restriction on R2? This quantity should not be negative. That means this quantity should be 0 or positive. So domain should be those elements of R2 for which the quantity x square minus y square should be greater or equal to 0. Means what? Those elements of R2 for which x square is greater or equal y square. So what are those points for which x square is greater or equal y square? So try to draw the graph y equal to plus or minus x. So this is origin. This is y equal to x. This is line y equal to minus x. So which is the part where square of first coordinate is greater or equal square of second coordinate? So is the domain contains the boundary, these boundaries, y equal to x, y equal to minus x? Yes, because equality would be there. This is y equal to minus x, so y square will be same as x square. This is y equal to x, so y will be same as y square will be same as x square. So in which part square of first coordinate will be greater than square of second coordinate? So if this is 0, 0, so it has to be there in the domain because 0 square is equal to 0 square, 0, 0 point. So if I choose this point, it is 1, 0. So 1 square is greater than 0. Similarly, if I choose this point, minus 1, 0, minus 1 square is 1, which is greater than second coordinate 0. If I choose this point, so these 2 points have to be there in the domain. Now if I choose this point 0, 1, so x square, that means 0 square is not greater than 1 square. So this should be my domain. Half part of first quadrant and half part of fourth quadrant, including boundary. And this part, half part of second quadrant and half part of third quadrant, including boundary. So union of these two regions is there in the domain. And again, what will be range? By the same logic, the minimum value of x square minus y square should be 0. So the minimum value of the function will be 0 and the maximum value, largest value, would be depends on the values of x and y, and this can be enlarged.